Hello and welcome back to College Algebra, MAT 150. In this video we will discuss the distance and midpoint formulae from section 1.1. So the distance between two coordinates is just the absolute value of the difference. The distance represents the gap between the two numbers. And again, in one dimension, this is easy to see. So between -3 and 2, so if we start back at -3, -2, -1, 0, then we have 1, 2. What is the distance between these two? Well, it's just how many units you've walked. 1, 2, 3, 4, 5. So the distance is 5. But what you can just do, instead of thinking about it reverting to this, we can just use math. And the distance is just the absolute value of the difference between the two. So take one number, subtract the other, and then if it'd be negative, just make sure it becomes positive. So -3 minus 2 is -5. And recall that the absolute value is just the thing that makes positive. So if it was positive already, it does nothing. If it's 0, it does nothing, but if it's negative, it makes it positive. So without actually writing out the number line, we can just do it like this. So it's easy between two coordinates. But with two full points, we could have something that looks like this and this. And we're still trying to just see how far it is between these two, but it's not as easy as just seeing the individual units. So what can we do? Well, we can use this formula. And this formula comes from a mix of the Pythagorean theorem, which if we look at this little thing I drew over here, between the 2 points, we can actually sort of we can extend some lines and actually make a right triangle. And this distance in the bottom represents a change in x, and this distance up here represents a change in y. So change in y, x squared plus change in y squared equals our hypotenuse, which we're just calling the distance squared. And to solve, you square root both sides, and that's where this formula comes from. So again, the formula just requires you to take the difference of the two numbers, square it, take the difference for the x coordinates, take the difference between the y coordinates and square it, add them together, square root, and you're done. So, and again, when I say this delta x and delta y, usually it's written as final minus initial, or y subscript f y minus y subscript I, or you can write it either way. But again, the delta just means a change in or difference between. However, points aren't initial or final. Usually that's referring to time or some other things like starting location if the direction matters, but for our case it does not. As long as we use the same coordinates for the same point, so even if I called this one x2s and x2, y2, and this one x1, y1, it wouldn't matter. So what I'm saying by this is, well, let's do an example. Let's use the formula. Let me scoot this up. D equals the square root of the change in x coordinates. So again, it's always x then y for your coordinates. Let's just do this. Let's call this the first point and this the second point. So the x's, let's just subtract the x's. So -2 minus 1 quantity squared. That's the first part. Plus, and then we have the, so let's just do 5. So we started this one being first, so we're going to keep that one being first. 5 minus -1. And then we have -2 minus 1. So -3 squared. Minus a negative is plus. So we get 5 plus 1 is 6 squared. And we have -3 squared, which is 9, plus 6 squared is 36. 9 plus 36 is 45. And it's still under the radical. Okay, and to address a quick thing I just noticed, Here, I just said that this was the first point and second point. Again, it doesn't matter which one is first or second, as long as you pick one and just stick with it. So we could have just as easily done the 1 minus negative 2, which would have been positive 3. And then we could have had negative 1 minus 5, which would have been negative 6. But because they were both squared, it still would have ultimately been the square root of 9 plus 36 in the end, which equals the root of 45. So this is a fine answer, but you may be asked to simplify it sometimes, and we will cover that in more detail later. But for right now, I will show it without giving it too much fanfare. The root of so 45 can be broken down into 9 times 5, and you can square root each one of these individually. And then the root of 9 is 3. And the root of 5, we can't simplify it. So this is an alternate, what is called simplified version of the above, but the above works just fine for now. All right, so that's the distance formula. Let's try the midpoint formula. So the midpoint is given by this, x subscript, so given 2 points. It's basically, so midpoint is a point, which means it better have an x-coordinate and a y-coordinate. And the way you find the x-coordinate and y-coordinate, you just average the two. So add this one plus this one, divide by 2. Add this one plus this one, divide by 2. It's an average. So, and usually you don't have to keep it in sort of point form the whole time you're calculating it. You can sort of calculate the x midpoint first, then the y midpoint if you want. And that's exactly what I will do. So I'm trying to find the midpoint, so I will calculate the x midpoint first, and I'll call this x subscript m for the x midpoint, x coordinate of the midpoint. And then we just take the two x coordinates, negative 2 and 1, and we add them together, and then we divide by 2. Negative 2 plus 1 is negative 1, and we have negative 1 over 2. A fraction is a perfectly fine and acceptable answer. Oops, well. Similarly, we can do this for the y midpoint. We just average the two y coordinates. So 5 plus negative 1, and then divide it by 2. 5 plus negative 1 is the same as 5 minus 1, which is 4. 4 halves is the same thing as thinking about 4 being divided by 2, which is 2. So we now have our x midpoint, the x coordinate of our midpoint, and the y coordinate of our midpoint. So our midpoint is just the point with negative 1/2 as the x coordinate and 2 as the y coordinate. Box our answer. That is all for section 1.1, part 3.